That's what makes Neutrinovoltaics so extraordinary. Autonomous, decentralized energy supply changes society.
What do you think are the main reasons why we're not using these fuel-free generators yet?
Our studies, our technology in Germany, were no longer published.
Are people today ready for it?
We're at a point today where it can't be stopped.
With us today is the founder of Neutrino Energy Group and acting CEO of Neutrino Germany, Holger Thorsten Schubart. Welcome to the show.
Welcome to you all. I'm delighted to have the opportunity to speak with you today.
We are pleased to be able to speak with you. In your interviews, you often say that the amount of knowledge you've gained is staggering. Through our process of researching information about neutrinovoltaic technology, we can admit that this is true. We would be very happy to share with our viewers these amazing discoveries and perspectives that are opening up thanks to the introduction of this new FFG technology. And, of course, we would like to thank you for taking the time to do this interview with us and our viewers today. Here's the first question. How did you get into neutrinos or neutrino technologies? What was your motivation?
It was a long road. So we're sitting here today in the year 2023. And it's been pretty much 15 years since I first came across the subject. It kind of runs in the family. So my father is a nuclear physicist. My mother is a chemist. So to me, science was always exciting, although I made a living from real estate. Remember, in 2008, the word neutrino, nobody knew that. And in 2008, we attended this experimental setup in Switzerland, in the Gotthard Massif, 200 meters deep below ground. A professor from the ETH, he demonstrated an energy cell, and the students who were there at that time. My father was there, and a couple of friends, of course, asked, where does the energy come from down here, in this isolation? And the professor said the word neutrino, which was the first time I ever heard it. It's a word that most of the audience had never heard before, and that was the first time it was said, neutrino. Neutrinos? What is that? At that time, this was a topic that was discussed once in half a year in some scientific papers. Something postulates that there is no mass. It doesn't actually exist. Simply a not postulate. But somehow, this word was already exciting. It has such an energy, neutrino. And somehow, there was something to see. Energies were to be measured. And there, this virus neutrino captured me. In the following years, I got involved in that research arena with the first investments. I was asked to invest money. And I really enjoyed doing that because I found it exciting. Because I was inspired by what it was all about. To develop a solar cell that didn't need light anymore. That was incredibly interesting. And this neutrino was a mystical element. And at that time, it was considered massless, non-interactive. And we know today that this is not true. That's exciting because then, in 2012, where I decided, because the lab results were so good, that we said, let's commercialize that now, whereby I didn't know what I would set off with it and which difficulties I would get myself into. But I said, I think that's good. I'll do that. We'll commercialize that. And so we called that neutrino and said there's energy there. We'll call it neutrino energy without knowing what it is exactly and what phenomena are behind it. Today, we know for sure. I'll come to that later. Then we protected these trademarks, these terms, and got started, and we're proud of the results. And that's how the whole thing started.
And that's interesting when you understand it. Maybe you can share with the viewers what the fundamental differences are between this neutrino technology, neutrino energy, and the alternative energies, or the energy sources that we use today.
Well, first of all, energy has to come from somewhere. Today, Energy is generated by burning fossil fuels, for example. Something is burnt, steam is generated, heat is generated, that drives turbines, generators, and electricity is generated. And solar cells. That's been done before, by the way, what few people know. That all started in the 50s. Most people think it started much later. And the approach was to say that there is not only light, but there are many other radiation spectra, including these neutrinos. But that's only part of it. We know that today exactly. And the question is, fundamentally, here are two questions that have to be answered. The first question, is there energy around us? That's the first question. That's the first question that has to be answered. And the second question, can we find a technical device, a converter, a tool, and how does this device work, which is able to generate electricity from this energy? And today we know we can answer yes to both questions, not only because of the neutrinos, and they can be measured today. They have a mass, they have energy, which can be calculated mathematically. How much energy comes from that? A lot of other radiation is all around. So we know today we have a lot of energy around us, not just light, but a lot of other fields. And the second question is, what do we do technically? How do we get it technically solved that the direct current, alternating current is created? And I say, give the people the example, trees. What does a tree have to do with it? I say, look, 500 years ago, someone saw the leaves moving on the trees, and when leaves move, they only move when energy is involved. At some point, a resourceful inventor had an idea of creating a windmill. Then someone built a windmill, perhaps, meaning the power that moved the leaves now drove the blades of the windmill. And from this idea, the flour mill, and today, the wind turbine were developed. And what do? We don't really do anything else, if you think about it. We convert kinetic energy into electrical power. And how do we do that? By simply developing a converter based on a material that has only been around for a few decades. A few years, you might say. It's called graphene. It is a so-called two-dimensional hexagonal carbon that has very, very, very special properties. It vibrates, and it moves in concave and convex waves in a so-called wave motion. And only because this material has these special properties, just because of that. We don't want to break the second law of thermodynamics, because that doesn't work. And we want to be able to be in harmony with physics. We find that we have different materials with two different vibration behaviors. Silicon and 100 times stronger vibrating graphene. And because of the different vibration behaviors of these materials, and only because of that, this technology works. That is called two-dimensional material. And we have this three-dimensional material behind and in front. And the two-dimensional material tries to move and releases impulses. And then we're already back to quite normal physics. What physicists call oblique scattering as far as electrons are concerned. And then it's just a matter of directing electrons in one direction. To do that, without being too technical right now, surfaces are being doped. The result is that electrons start to flow in one direction. And that means electricity. And this way of generating energy through the vibrational behavior of carbon, which is a patented process, is a so-called graphene sandwich. The correct term would be multi-layered graphene microvibration energy cell. Yes, of course, that's a darn bulky term. We used to call it neutrino energy. We face a great deal of resistance because most people have said that they're crazy people who want to capture neutrinos. And I would like to once again and take this opportunity to explain to you and to all listeners and viewers very clearly. We're not capturing neutrinos. The neutrinos practically penetrate the bodies. We don't capture them. Nevertheless, neutrinos do play a role. We know that today. They give a small impulse at the atomic nucleus, but we use the whole oscillation range. So we use the whole non-visible range of radiation. We don't capture the neutrinos. The neutrinos are the namesake. They are the trademark of our company. And Neutrinovoltaic is not a single neutrino because this is always a main criticism, but we use a non-visible spectrum. This has been very nicely demonstrated in the laboratory today. You can look at it. You can see what you cannot see with the naked eye. That is a problem for many viewers. You can recognize the wind turbine, but this movement that we're talking about, you can also see it if you look at it under an electron microscope, and anybody can see it when you Google graphene vibrations.
That's interesting too. You bring that up, the wind turbine. So wind power or photovoltaics. And today we see this technology, or these alternative energies. They are still very, very actively promoted today.
So I think already it is very good that we had this idea in the first place to get away from fossil fuels. And the idea behind the decentralized system. What we have today, what I see developing is that we say we don't need these big, strong rotating streams. We have a different system today. We have different electrical devices than 150 years ago. We need a few volts of direct current for our households, for the electrical appliances that we have. That means I don't need the central energy supply. I don't need the networks, all the costs, but instead, I get the energy device, because then my energy comes directly from where the consumer is. And we talked about this cell. Now, let's compare it with a solar cell. Everyone would now be privileged. They would have their single-family home. And everyone would have a roof surface with a solar cell, and the sun would shine 24 hours a day, which unfortunately, it does not. But now here we are, and what our cell can do is use a spectrum. And contrary to a visible solar energy cell, our energy is available 24 hours. And it has the advantage that it's a base load energy, everywhere and always available at different strengths. With it being available everywhere and at all times, I can operate every electrical device completely autonomously, basically any electrical device. We will discuss those devices in detail, how it will work with the appliances. We're not going to industrialize that. That's what the industry will be doing. What we do is providing you, today's society, with an initial thought process as proposing a solution. That is also our concern. We don't want to manufacture all these devices. It's impossible. We cannot build so many factories, but we want to enlighten for a social solution with a new thought process. 150 years after the development of the first energetic models towards an autonomous, decentralized, fairer energy. Energy supply has something to do with peace, with life, with education, with light. Those who do not have energy are not able to compete at all in today's world. Many continents are isolated. The wars that we wage today in this world, the geopolitical conflicts, always have their causes in the distribution of the last resources of fossil fuels. That means one world, that is my personal intention. Why I also lead this project is that I imagine if this kind of energy supply comes in the future, that the world can be a little better and more peaceful. And for this, it is also worth overcoming all these challenges and difficulties that I've gone through in the past 15 years.
And what is valuable here, perhaps also for our viewers, this independence, which, as I understand it now, the cube also offers, not only decentralization for every home, but the independence of the people themselves from these big grid operators, from centralized energy supply, because we have the cube at home.
Yes, but I think that's also the problem why it has taken so long. I believe that the system we live in is a systemic problem. That is, a systemic problem, which has provided the energy and requires every citizen to get electricity from the wall socket through power grids. That is, I don't even want to say that. That is a lucrative model for particular societies, but it is simply a dependency that has developed over decades or centuries. And an autonomous, decentralized energy supply changes society. And that's absolutely right. And it's not just about being more free. I always have a bit of a problem with the term free, but we live in a society in which if we have a blackout, regardless of whether it was due to military conflict taking place or simply because the power plants don't have enough capacity, or because we ourselves are now shutting down the power plants and perhaps blackouts will occur at some point because an ever-increasing number of people need an increasing amount of electricity, the power grids are very, very fragile. In other words, grids are always fragile, and if chain reactions occur somewhere in the grids, then the power grid fails in this society. People say, no, that won't happen. But you can observe this even in highly industrialized countries like the United States. And there, you just have to say, a decentralized, autonomous energy supply means we will always have our electricity in the power cube. Again, that's nothing but a folded solar cell that works without light.
24/7.
24/7. Much weaker. It has to be mentioned that actually, our energy is much weaker than visible light. That's why we have to use a trick. Trick. Invention. That's what it's all about. Our trick is that we create large physical surfaces. The energy created is much weaker. That's why in a cube like this, which looks very compact, but has up to 1,500 square meters of wafer surface area, that means that basically this cube is nothing but a fully giant-sized solar cell interacting with non-visible light. And that gives us a net output that we have now. We could have done this in another size, of 5 kilowatt output power, which is enough for a large flat or a small house. And if you need more, you just take 2. And the cube is just one, but the goal is also to develop smaller cells that can be implemented in electrical devices, directly in a television, directly in a tablet, directly in a cell phone. The way goes towards using little energy that is needed is basically always and instantly available. And everything, this central system, which binds people, which holds them. In the past, there was a telephone with cable. You could always go only where the telephone was. Today, we're also free regarding the telephone. We have cell phones. That was a technology 30 years ago, totally unimaginable. And it's the same with the energy. We used to have this for our TVs. I'll never forget how my mother wanted a TV in the corner. My father said, "But you can't. The aerial cable comes out from over there." Today, nobody has an aerial cable anymore. Today, it is transmitted via Wi-Fi. And energy is also surrounding us in the environment. The correct English term is harvesting the energy of vicinity. That's what we're doing. Neutrinovoltaic is an energy harvester. It doesn't produce energy, it converts existing energies. And we have a lot of energy around us.
For sure. And very important at this point when we're talking about this technology. How far has it been explored? Are there prototypes yet? And are those perhaps being used already?
Well, it's always a case that you can't reveal everything. So the one that is fully developed, I would say that the wafer, the converter, is fully developed. Today, you can say that what is fully developed is quite clearly how much energy output per square centimeter at what outside temperature it provides. That's all completed. It's technically and scientifically complete. If one gets away from the term neutrino, and no one tells that neutrinos are captured. But if one goes to the physical technical conversion of these oscillations into electricity, then one knows that it works. We put the word neutrino on it, but we are right to do so. One knows that. And now, you just have to do the following. Now, we're into normal mathematics. That is, we know x brings y energy. Twice x brings twice y. That's the way it is. And now the industry, and I emphasize that, the industry, because we can't do that on our own. But now, the industry, like with solar cells, simply has to do nothing more. We have to say honestly, that's the bottleneck, the industrial manufacturing. We know everything we need to know. We have a prototype today. And the big advantage is, not only do we have a prototype, but we have AI today. AI is artificial intelligence, which means that today we have the possibility, unlike in the past, when an inventor made a prototype in his basement. Do I have to make another one and another one? Do I have to make it again and again? Today, we have the possibility of computer experts that we have. We have an amazing team who are programming. And today, we can just say, if we know X about what we talked before, we're able to simulate all these technical devices on the computer one-to-one with a probability of 9 digits behind the decimal point. This means that today, based on the amount of energy, based on the technical possibilities, I can calculate the energy quantity for each technical device and also create the cell on the computer and skip the other 50 prototypes in other sizes. This means that we have few prototypes, but based on the measurement results and the simulations, we basically have the products ready for the entire broad range of applications and can proceed from the simulation directly to production. Yes, you can still make a 0 series. you can make a small pre-series. It's always possible that one or another problem will occur during the technical implementation, and that will happen for sure. But these are experts who are specializing in manufacturing. The right machines have to be developed to coat the wafers. That has to be put together. Jobs have to be created. That's a step the next generation is taking right now. We provide the knowledge, and we explain how it works. We have a great team of scientists. We're also helping with that. And we hope that in the next few years, I know they will, the industry will adopt these technologies.
You just mentioned problems a moment ago. I want to talk about what difficulties you encountered along the way of developing this Neutrinovoltaic technology. And how did you overcome them? Tell us about that path.
Actually, it was only problems from the beginning. So, when I look at the whole story today, I ask myself whether I would do it again. At that time, I started out naive and thought, okay, I'll help them and invest a little money, and then it will start somehow. And then, we had the coming out in 2014. We sponsored a federal press ball back then. I have to mention, and in retrospect, I have to say, it was completely crazy. And afterwards, an unbelievable shitstorm broke out. There was no Nobel Prize and nothing else. But today, I have to say that everything was right. All the difficulties that have arisen over the years. Blocked accounts, charges, denunciation. It's unbelievable, isn't it? I can only say, if you look at what happened there. I tell you here today, our studies, our technology in Germany was no longer published. That is, a so-called publication ban was declared for years. Can you imagine that? Article 5, Paragraph 3, Basic Law. There are issues, and I tell everybody that. I got goosebumps back then. How we simply tried to publish studies on these topics we're researching today. It was simply rejected, and I'm glad. So I'm also glad today that we're talking to each other, for example. That's what eventually reaches the mainstream. You can't suppress the truth and things in the long run. At some point, it will find its way. But this interview today will again inspire people to check up, to scrutinize themselves, to question, to recognize, and to develop. And so this is a great pleasure for me that you and I are talking today.
It's absolutely mutual.
And we have always basically grown though, gotten over each stage, and we have understood the meaning of it. Why it's all like this, why this resistance has increased. And I don't think there was anything that wasn't there along the path to where we are today. And some people say we were too early. I say we were just right, because all those difficulties built a foundation for what we have today. And I think that society, and I'll say it again, we have solutions. We don't have ready-made products. We have approaches to solutions. You can pick up on that now. And I think that for me, and that I've done something for society, where my children or grandchildren can gain something from. And I can say that I've carried a baton up to this point. I'm still carrying it for a while, and I've got great partners. New partners who are now taking it to exactly this next level, where it needs to go. Whether that's in India now, whether it's in South Korea, in many countries where it just has been understood that these products are now going into mass production. From that, in the end, everything will be right.
Here, you can say that maybe we are on the verge of discovering and implementing this free energy, or this technological revolution.
I think energy is not free, because no matter what I use, the wind, the sun, even my oil source, or even neutrinovoltaic, everything requires technical devices where energy is converted, either conventionally via fossil fuel combustion, or via the system that we have. I think that what free in this case means independent. So independent of. If you look at it that way, then the term free energy is correct, independent of the system.
What do you think are the main reasons why we're not using these fuel-free generators yet, this technology?
So I met a lot of inventors over the years, a lot of tinkerers. They were all good guys tinkering in their lab. I saw a lot of things, from magnetic motors, different energy cells, different foils, different transducers, all great. But they all actually have a problem, all the tinkerers. They either started too early or too late with their invention, kind of on their own. They wanted to go their own way. And we said, we'll go another way. We said, we'll take the way we understand. Energy is not something you find in a lab. It's an interdisciplinary combination of different faculties from different fields, scientific findings, materials, scientific findings in connection with astrophysical findings, general physical findings, findings of the new physics. That is a whole separate topic. Physical realizations are always current only so far, until something else has been recognized. And society does not stand still. And the strength of our system was simply the connection of interdisciplinary different areas to network, to connect, and also to let different scientists speak, and not to say there's only one of them. But we had an idea, and we asked others who have made it a little better. And then we were joined by others who also had ideas of their own. It was a community. That means if someone asks me today, who is the inventor of Neutrinovoltaics? I have to say yes. We generated the term as a company, but there were a lot of tinkerers and hobbyists who contributed their share over the years, who contributed to the fact where it is today. And it is far from the end. But today, we're at a point, like in the solar cell 30 years ago, where one now understands, and aha, we now understand what it is all about. And now laboratories, state laboratories, private laboratories, and tinkerers are called upon to use this basic knowledge to make things even better for society. That is also what we have done. We have published this. We've explained it, and I'm pleased that many asked whether we have competitors. I say there are no competitors for me. This is a social issue, what we do. And I'm happy about every publication where a university, where a tinkerer, an inventor says, I got something else. Here, you can do it a little bit better. And I believe, if you look at it that way, in neutrino photovoltaics, there is now a possibility to create something together for society concerning an alternative to conventional systems. If you have this understanding, I'm satisfied.
And that's also interesting that you bring that up, that it's to your advantage if you include scientists and experts and researchers or inventors from many countries and put them around one table. Accordingly, the result you get regarding this technology will be much more quantitative and qualitative.
You know, I would so wish that this world order would be a bit more peaceful. And the problem is actually that now even politics is trying to interfere with invention. Politics is trying to play politics. I always say that it is trying to rule into science as well, and to gain advantages for itself, individual advantages, and not for the benefit of the general public. We have from all over the world, from quite a lot of countries, scientists, and I've always said that we, as a team, are non-political. I don't judge any of my scientists for what their governments do. That has always been a basic principle for me, and we coexist in peace as scientists. I have that insight. Compare it to a space station where people from different continents, even if their countries are at war, have to get along with each other within their microcells. And we all have to get along with each other. And if you understand the issue that we're researching, the energy, which is also the issue basically, why all these conflicts are happening, then it will be all the more. And if you take all these billions and billions that are being spent in weaponry that could be used to provide people, energy, food, education, all these issues. And I have to tell you quite honestly, even what we're doing today, we as a private company, that is actually a state mandate. That is normally a mandate from state companies that say, we're doing research. And now, I'll tell you something. We're at the point today where you can't stop it. We're at a point today where too many people have understood how it works. And we will now continue right there extensively. That is, we're going to 500 or 1,000. We've gone to India now, unfortunately for now, but maybe we'll come back to Germany or to other countries, just with the necessary resources, and trust the right engineers with the right task. And they'll sit there until it's done. That's what man is capable of doing. He is able to create a solution from the basic knowledge. That is the brain of a creative engineer. And as I said, not just one thing and another, but interdisciplinary cooperation, plus the possibilities that we now have with artificial intelligence. That is to recalculate tests and measurement results in a much faster dynamic. And then we come back to the old values. Geometry, for example. Geometry is a very relevant point because it is also important for us to develop a system that is cost-effective, conserves resources, is environmentally compatible, because it has to integrate into society. And if you take all of that together and add to the possibilities that we have today with quantum computing, with the supercomputers, with artificial intelligence, then we'll find a solution we need, because we need them now. If we don't implement the solutions that we have, our children and grandchildren will no longer live in peace and quiet, or in a good climate in this world. And we notice that every day. It's high time to do it now.
And that's also the next question. How does neutrino technology benefit people? What can this technology change for people?
I think every device that has a battery in it today will have a converter in the future, or a capacitor. Looks like a battery, but has a higher output capacity, a lot more environmentally friendly. That means you can achieve autonomy. That is, everyone knows it desperately. The cell phone is empty, and he doesn't need that. And that's that. As I said, we talked about home supply. The other topic is electromobility, where we're developing the Pi car, where we just say, right now in the summer, most people know that the car is hot. You get to the car, it's hot, you get in. Heat. What is heat? Heat is energy. Here's what we're doing. Engine on, air conditioner on, windows down. Energy is being dissipated, and what we really want to do is just not dissipate that energy. We want to use it. It's a waste product. We want to use it. And we had talked about our cell that vibrates, and the cell that vibrates is not glued on the body of the vehicle. Also, to clear up another misunderstanding, we would not have enough surface area. A vehicle has maybe 10 square meters. You can put solar cell on it, but that's not enough. But we can go into the third dimension. That is, we weave our material into the body of the vehicle. We don't take metal, we take carbon. Then we have 200, 300 layers. And then we know, if we say 10 square meters of surface area times 200 on 2,000 square meters of surface area, times multiplied by the energy output per square meter X, multiplied with watts. I know, what's the point? And then the car is on the road. It's on the road anyway. And then, while it's standing there, and all this energy that manifests itself there is converted into propulsion. That's roughly just on a scale for the average consumer. 1 hour of parking at an outside temperature of 20 degrees, 100 kilometers of driving without a charging cable. That is autonomy and genuine, honest green locomotion. And then I don't have electricity from the socket, from the lignite-fired power plant. The advantage is simply this. We don't use coal and oil, fossil. We use a non-visible radiation spectrum. That is a medium that is permanently present. Light, energy, radiation. Simply, we have an evolutionary development. We use lasers. We work with computers. But we have power supply. That's early industrialization. We don't do anything else. Like this evolutionary step that you missed. The last 50 years, this evolutionary step towards a converter technology. Just take it. And this step is technologically feasible and must be implemented consistently, not by one person alone and by one team alone. This is a government mandate. And now countries like India, for example, understand this because they have such problems, such air pollution, such a crisis. The crisis must be so severe that the pressure of suffering is too great for people, and they say, we can't do it anymore. We have to do something now. It's getting too late for the globe as a whole. We're close to midnight, and they just keep on going. There are many people who have understood, but the power of people was not there to bring about the change. And the ones that tried, the great developers, great tinkerers, they haven't muzzled immediately. They came up with their idea and said, I got something. Shut up. They were denounced, they were attacked, and at worst, they were put underground. And that's a drama. In society, I think society today is ready for the transformation of knowledge and new technologies because simply the pressure of suffering becomes so high and people don't put up with anything anymore. Also due to possibilities like the internet, dissemination, and information. They understand. They question things. You just have to understand everything comes in time. And for this technology, the time is just starting now.
That's a question I'd like to ask you as well. What role does the level of moral development of our civilization, of humanity, mean or play? The moral values of society.
They differ. I think that we live in a world order that has very differentiated values. And I think that we as Germans also have or make a very big mistake when we try to give other people, other cultures, other religions, I always have the example of the globe. Because when I see my grandmother's globe and look at it, I always see Germany very small. When I look at a map and see that Germany is big, I know that it's not to scale. And I believe that it is a very big mistake to try to tell others what they should do better or differently. I believe that in a society in which we live, you have to respect the values and other opinions. That is one thing. And it's just that we have other cultures, other religions, other politics. And of course, it's difficult to achieve harmony. That's why I believe that the cause of the problems is dissatisfaction. That is, conflicts arise from dissatisfaction, hunger, and poverty. That is, if people have access to clean drinking water, enough clean food, clean energy, if they have their families, then at least, I don't want to say they don't fight anymore, but at least there is immense potential. The potential for fighting in this world is no longer there. And then, if you understand that in the next 20, 30 years, 2, 3 billion more people may be living on this planet, if you believe the demographics, then you have to understand that if you don't find alternatives today, these problems are going to worsen. That means that we'll see more catastrophic conflicts. And then you also have to understand then it's about human rights and things in the media. But if you look deeper into the conflicts, if you're quite honest, I'm not going to condemn anybody here today. No state, nothing. But if you look at all the conflicts, at what they're really about, you find that human rights always play a role if there happen to be mineral resources in the area. That is, if geopolitical interests have to be represented, then human rights also have to be represented, and that is not okay. In other words, human rights must not depend on whether there are mineral resources in the country. And if there are natural resources there, then people will look the other way if any human rights are violated in this country. And this is a kind of policy that we see again and again. And I have to say, that makes me personally very sad. And therefore, I think this autonomous energy supply is part of it. One must be realistic. In 10, 20, 30, or perhaps also only 50 years, the children and the grandchildren will have made the world into a somewhat different one than we have today.
So, are there universal values that we can rely on as humanity so that we have a common denominator? Are there universal values that you might describe, that can support us?
Yeah, so for me, it's like this. The values are simple. The basic value is living together peacefully, interacting with each other peacefully. That's the basic value. And everything else. I have to say, for me personally, I can live with everybody who is not radical and respects others. It doesn't work any other way anyway, because that's the task of society, living together. You can look in the animal world. That's how it is. And human beings in the way they are in their different systems. By the way, the advanced civilizations or alleged advanced civilization that we had in the last centuries or millennia, they all disappeared at some point. And that's the thing. A journalist asked an Arab emir about his wealth. Yes, my grandfather rode a donkey. And today, I'm driving Rolls-Royce. And my son, he will also drive Rolls-Royce. But my great-grandson will ride a donkey again. And then the journalist asked, but why? He answered, quite simple. Hard times make strong people. Strong people make good times. Good times make weak people, and weak people make hard times. And that is precisely the problem of our society. That is what we're experiencing here in Germany. We're living off what fathers and great-grandfathers built up after the war, after this catastrophic time. And today, we have a society that is focused on consumption, that is not very value-oriented. Consumption is important. We have forgotten to really focus on values and also to provide for society for the next decades. And I believe that it is high time now, really high time to rethink everything.
There's another important question. It is about a new technology. With a new technology, we recall an exploration of nuclear power, and along with that, atomic bomb. How do you see this danger?
So energy is always energy and always has a risk of being misused. For example, in development now, we do the nautic pi for boats. We do the pi car, and we also have a theoretical possibility to use this technology for flying objects. What we do in our talks with industry is that we emphasize that we place a high value on a conscious use of our technology for peaceful purposes. But on the other hand, we have to recognize you're not a fantasist, that the automotive industry, I don't want to name a manufacturer, there are engines being put into combat vehicles. The war industry is abusing things. And at the end of the day, this technology, which we're developing, energy, of course, will theoretically be used in non-peaceful means. But I personally believe that if this technology just removes the causes of geopolitical conflicts, then at some point, they will become unnecessary. That someday, maybe in 50 or even 100 years, we will live in a form of society where this kind of stupidity, for me, is always. War is when diplomacy fails, when you just can't find solution. And this kind of stupidity comes to an end. And if you have, I don't want to say abundance, but if you just have energy, and you have water, and you have education, then you have gained a lot to make it safer and better.
You can really confirm that energy should really build today a basic principle of conservation law rate, which should actually benefit all people. Because if today people were without energy, where would we be then?
We have a whole continent, Africa. One of the most densely populated continents is virtually without energy. One should know. We have refugee flows. We have problems. People don't come here because they don't like it in Africa. They come here because life in Africa is not worth living. And then they pay a little bit of development aid. I believe that we should build up this continent better to help people, to counteract malnutrition, poverty, and not to invest billions in weapons. That's where we need to invest. That's where you need to go. That's where you need to help people. And I believe that it is precisely these decentralized, autonomous systems where there's no electricity at all today. In our country, people say, I don't need it. I have electricity from the socket. But in places where there's no electricity today, these systems will be the first to have a real breakthrough. That's what will happen.
I would like to address the issue of responsibility. When we take possession of inexhaustible and free energy, what also means a high level of responsibility, if they understand that this responsibility is the consciousness of those who have this technology, what do you think about it? Are people today ready to take this responsibility?
You know, at this point, I have. Because many always have said, can you carry this on your shoulders? I said, I've handed it out now. Do you know when we did it? We handed it out by declaring it. That was very important for me. That was also important to protect myself, to protect the family, to protect the scientists. Actually, today everyone, and we reassured us, that was the intention behind it. Today everyone can see how it works, if they're keen about the technical documentation. In other words, society bears a responsibility now. Society has a responsibility to pick up this knowledge or ignore it. Every politician, everybody to say, I'll pick this up and move on. And then it goes on as normal. those who are simply the pioneers, and that can't be carried in the long run. It's too heavy. The responsibility is too big. I say the baton will be passed at some point. And if the next level now comes along, the next level means universities that take up these findings and with students, as it happens in India, simply take the further development, that government agencies simply take care of it, to take up the findings and develop them further. And I believe that society then will recognize the advantage very quickly at some point. There will be some resistance from people who don't like it, of course, because disruption, or so-called leap innovations, also change markets. But in the end, I believe that what is good will prevail. And that has a decisive advantage for society, not only in terms of costs, but also autonomously. We have already talked about this a bit. I think if society as a whole recognizes what the benefits are, they're not going to let themselves be deprived of this technology in the long run.
These are also the conditions that have to be created in order to quickly initialize implementation of such a technology in society.
I also think if people know, they will demand it, and the industry will eventually bow to that by just giving the consumer. Just imagine, when the first one starts using these devices afterwards, it's going to be like flat screens today. Do you still want a cell phone without a flat screen? They don't want to, and therefore, I think this development will go its way.
Here's another question. How can we safely and quickly move away from fossil fuel dependence, given the rate at which climate disasters are increasing? As you said just a moment ago, we don't have much time left.
Finally, it's always a mathematical question. Mathematical question 1, how much energy do I need? When and where? Mathematical question 2, where do I get it? And if I understand that we have new approaches, then I can solve those questions. I just have to not listen to the lobbyists who are selling me the old, but just ask the scientific team, be controversial, try things, and find solutions. That's what humans have always done. Already thousands of years ago, flint was invented. When you invented the steam engine, invented the computer, that these are evolutionary technologies. They go their way, and we have the opportunity today to recognize that. Only with the topic of energy, it was suppressed for decades. People were just suppressed, and that's over now. That is, the topic goes to the public, is in the public. The researchers, together with the technicians, are implementing it. And then, we also have the answer to your question.
We want to come back to the question, under which conditions is the rapid adoption of this neutrino technology in society possible?
For me, it's like that, awareness. The first step is perception, that if it's perceived, then people start being creative, even if it's just a few, but they're in on it. And the second is the public that demands it. Most just don't know. They demand something, but they don't know what to demand because they don't sit at the science. But when they all find out what is possible, then they will simply demand it either through their students, that is, through the teachers, through their education, through the industry. And I think that's going to happen. That's why education is important. And that's why you can't let people stop you from giving education, that is, knowledge, to the outside world. Knowledge is still the most important thing. Knowledge. That's where we try to do something together.
Do you think that the theory of the standard model will have to be reconsidered in the near future? Because on the internet, there are new findings about the structure of elementary particles, especially about that of the neutrino, and about the interaction of particles, about the principles of the manifestation of the elementary particles, their disappearance, and especially about the medium in which the elementary particles fly.
Yes, I have to say, I microthink that the model, the standard model, or the model of physics, we had to rethink that so fundamentally every 50 years. The bad thing is always that society thinks at the point where we are, there's nothing more to come. That's always been the case, and that things are always evolving. And especially with regard to the standard model of physics, we're directly affected by this. You simply have to realize that today, we're moving into other, different dimensions, not in size, but in
microcosm.
Yes, microcosm. We're advancing into such a microcosm because we can look inside today. Today, we're able to look into microcosm technically, that is quantum mechanics, things like that. We didn't have that in the past. That's why we used to have the other standard model. It wasn't wrong then, because we didn't know better then. We know better now. The problem is simple. There is a gap. There is so-called knowledge gap. Knowledge gap means for me, there's scientists who invent something. They have findings. Then they publish them. But there's still no validated literature. It's new. Where should the peer-reviewed papers come from? Where no peer-reviewed papers are new. Or do you say, what do you have there in the way of peer-reviewed papers? No, he can't have that. That's new. Nonsense. So, and from that stand, he starts convincing colleagues, and then one and the other jumps up. Then the top scientists get it. But then, they ask somebody from the street, or the textbook physicist, and the all nonsense. He opens his book and says, all stupid stuff. And from this so-called knowledge gap, that is, between top science and knowledge in society, there is a glaring gap. Whether that's 10 years or maybe even 20 years. The problem is that you have to understand that, of course, knowledge is change, because knowledge means possibilities. And when there is such a glaring gap between the knowledge of a few and the knowledge of the masses in society, what usually happens is that the few acquire this knowledge for their own benefit. In this respect, Europeans have not been very knowledgeable in recent decades. When you realize that all cutting-edge technology has migrated abroad because we were simply too slow, because we did not dare to do anything. Initial findings do not mean that it is ready, but initial findings. It means you have to try. You have to be brave. You have to take risks. Nobody took any risks. On the contrary, those who were brave and risked something were insulted. And that's also what happened to us. We were called names. Scientists, physicists, partners of ours were insulted. And I think this is a problem of society. But you have to be open to results. Research can also fail. Research means to develop knowledge and to fill this gap as quickly as possible. To look ahead a little bit. Scientists don't ask the politicians, not the lobbyists who defend the past, but the future. And if we look at the neutrino, that's even more exciting overall, because this word neutrino also has something mystical about it. When you say that we're all actually energy, we're all actually neutrinos for everyone. What are we then? And I think if we could close our eyes and say, we go 100 years further, then we'll probably experience and see technologies and things which we cannot imagine today in the wildest dream. And that's where people just have to be ready to move forward. And they also have to endure. That's so okay for me today. I had to endure it, but I'm glad that I endured it.
You call neutrino energy a game changer for power generation and electromobility. Tell us why, please. What prospects does harnessing the energy open up for all of humanity?
So if you scale that thinking, so we have today laboratory result. But we have computer simulation. That's done. Prototype, computer simulation, results. And now you have to, like you did in the decades before, from that. And that helps. That's where the technology that we have, computer technology, helps very accurately. That is, from these calculated results, these manifested results, I calculate the models for tomorrow. And there, I can calculate that on this form of energy, which is not limited, which does not produce CO2, 5,000 years of world energy demand per day, radiation energy per day, more energy unused radiation than all fossil fuels. Then I must understand, there is some energy. And from this realization, this energy for all mankind, the most capable minds are called upon to create solutions and not to produce something. And I want to say that again at this point. There are many exciting approaches to producing energy, but we don't have to produce anything. We just have to take what's there. And I think that's what makes Neutrinovoltaics so extraordinary. It's first of all, no mechanical parts that can break, and then nothing has to be produced. But we take what's there, and we take a resource as we dug it out of the ground. Now, we have from above we're now no longer oriented downwards, we're oriented upwards. Perhaps also more cleverly, to the light, one would say, and have simply arrived at a stage of evolution where we're from our capacity, that is a mental capacity, plus the technical aids that we have available, in a position today to use this energy. Today, we're in a position to use it. We today are in a position with society to implement it technically for the benefit of all. And that's where we want to go.
And very importantly, our last question, how do you think the world can change if science and technologies were to serve society? How will people's daily lives change if everyone had energy available in any quantity?
I think the hardships and the imbalance of society would stabilize very quickly. There will always be poor people, and there will always be rich people. But I think what it comes down to is this extreme poverty and this extreme discontent based on that, and this extreme imbalance. And when that extreme imbalance is stabilized a little bit, that potential for conflict will no longer be. I think that we always have differences, but that a world with less big differences. And very few people know that. I came back from India a few weeks ago, and I would recommend to any German or any European who lives in their affluent bubble. It doesn't have to be India. There are a lot of other countries with extreme poverty, with extreme difficulties, to just go there for a week or 2 or 3, to have a look, to get an impression. What's actually going on in the world? And not just to see one's own microcosm, and then understand that yes, we live in one atmosphere, in one world, and we can't compartmentalize it. And that society, as it is, with increasing and increased population, has to find ways to get along without otherwise wiping ourselves out at some point. And that's either by shooting at each other with nuclear weapons, if we simply can't get the conflicts under control, or if we make the planet we live on no longer worth living on. That we say, in 50 years, in 100 years, our children, grandchildren will no longer be able to live. And that's why each one of us is called to just do things with our possibilities, and if only to contribute to bring knowledge forward.
If you were to make an appeal to the people in the audience, what would you say?
Look in depth. Get to the bottom of things. It doesn't just apply to our technology. It applies in general. Don't let the things that are given superficially always sell you as truth. Sometimes the truth is much deeper. And be confident. Orient yourselves towards light. And I think it's out of the darkness. There are for the society. We have problems, but we also have opportunities. And I think if you're oriented to the hope and to the future, and if you see those opportunities and you're oriented to the opportunity, if you want to take advantage of the opportunity, then together we can make a difference for this society.
Mr. Holger Thorsten Schubart, thank you very much for these sincere words, for the interview, for your time, and for this wonderful conversation.
That was a great pleasure to do this with you.
Thank you.